Hey guys, how you doing? Kenny here. So today we're going to go ahead and take a look at geothermal energy, and then in the very end we'll talk just really briefly about hydrogen as a potential fuel source. Okay, so let's jump right in and get to our essential questions. Number one, what is geothermal energy and how is it produced? Number two, how are the three types of geothermal power plants different? Number three, what are the advantages and disadvantages of geothermal energy? And number four, what is hydrogen fuel and what kind of future does it have? Let's start by taking a look at the basics of geothermal energy. So what is geothermal energy? Well, geo, the prefix, means earth, and thermal means heat. So it's essentially heat energy. So geothermal energy is energy that comes from the ground, power extracted from the heat stored inside the Earth's core. Now, you probably remember back to your middle school days going over the different layers of the Earth. We've got the core, which has both the inner and outer core, the mantle, and the crust. So we're up on the crust, but coming through the crust, when we have volcanic eruptions, earthquakes, these types of things, we can see some of the heat escaping from the mantle. That is geothermal energy. So it comes from the heat stored in the soil, underground rocks, and fluids of the Earth's mantle. It has great potential for supplying many areas with heat and electricity. It has a generally low environmental impact. However, the sites where it can be produced economically are more limited. But remember that this is 100% renewable, and the Earth's core is always going to be heated, well, as long as the planet's alive. And as long as there's a way to extract the energy from the heat, the energy will always be available. So when we start thinking about this in terms of fuel access, again, it's a very unlimited resource. So good, like a lot of our renewables. How do we use that energy? How do we use that heat to go ahead and produce energy? So first of all, you have to have pretty hot temperatures. Temperatures hotter than the sun's surface are continuously produced inside of the Earth by the slow decay of radioactive particles. People around the world can then use the geothermal energy to produce either electricity and heat their homes by digging deep wells and pumping heated water and steam to the surface. So where do we find this geothermal energy? Well, it's found along major plate boundaries where earthquakes and volcanoes are concentrated, areas where you see a lot of geysers or hot springs, what they call fumaroles, geothermal reservoirs. Probably one of the biggest hotspots on our planet is known as the Ring of Fire. So any place you're looking at things like plate boundaries or places with a lot of volcanic activity are going to be good sources of geothermal energy. And here is that ring of fire that we've talked about, where we see a high level of geothermal activity. And these are probably going to be some of our more optimal places to extract geothermal energy. It is around much of the Pacific Rim, where we see a lot of these earthquakes and volcanic eruptions. It's kind of this little horseshoe shape you see here. It's about 40,000 kilometers long, up to about 500 kilometers. This is just a very active region. You can see the west coast of the United States, as well as up into Alaska, Canada, and all the way around the east coast of Asia and down into the South Pacific. And all along this ring of fire, you have a bunch of these types of views. Okay, this particular one is Volcanoes Bromo National Park. In Bromo, Tengger Semeru National Park on the island of Java in Indonesia. And it's the home of several active volcanoes, which can be seen here smoking ominously against the blue sky. All right, so this is where all the sites are located. What kind of energy systems are we going to go ahead and use to extract energy from these types of locations? Well, first one that we're going to take a look at today is a geothermal heat pump system. If you have a heat pump system in your house, it's related. We're using the heat of the ground and the cooling of the ground to go ahead and change the temperature of the air that we're going to force into the house. These are very energy efficient and reliable, environmentally clean, and cost effective to heat or cool smaller spaces. Maybe not for your entire house, but very easy to do for, like, say, a bedroom, okay? Or maybe two, three. Okay, the next one is direct use applications, where we actually take the heat from the earth to heat something, okay, without converting it into electricity or anything else. Sometimes they'll even use the heated water itself. People go and bathe in hot springs. Okay, that's a direct use application. We'll use this to help heat greenhouses, to heat water for fish farming, to help pasteurize milk. You can use this for food dehydration, gold mine. So there's a lot of different applications. And then lastly, we'll go ahead and start looking at the power plants. And these are obviously there to produce energy, but there are several different kinds of electricity power plants that we can talk about. Let's start with those heat pumps. Geothermal heat pumps work by tapping into the renewable solar energy stored in the ground to provide savings of up to 72% on heating and cooling costs. Although it operates similarly to a standard heat pump, which some of you may have in your house, a geothermal heat pump exchanges heat with the earth instead of with the outdoor air. And you can see that in the example here. The cold water goes into the ground, comes back warmer than it is outdoors, or the hot water goes into the ground, comes back colder than it is outdoors. So then we've got our direct use applications, and there are tons of these, and probably one of the most famous is in Iceland. Iceland is one of the countries that is considered the cleanest on our planet. They use a lot of geothermal, and it's used to directly heat individual buildings and to heat multiple buildings with district heating systems. Hot water near the Earth's surface is piped into the buildings to produce that heat. And the district's heating system provides heat for most of the buildings in the city. And it's not a tiny little city. It's a major city as far as Iceland is concerned. And so you can see a picture of Reykjavik right there. And so you can get an idea. So now I want to watch a quick little video that's going to go over the basics of geothermal in terms of power plant production. And we'll talk about them a little bit more as we go ahead and go on. So enjoy this video. Okay.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Okay, so when we start taking a look at geothermal, it's just one of several different options, obviously, but this one has relatively few impacts in terms of the environment, at least on the surface. There are 3 types of geothermal power plants that are identified in the video, and let's go over those really quickly here again. You have a dry steam plant, uses steam pipe directly from geothermal reservoir to turn the turbo generator. Or you can do a flash steam plant, which takes high pressure hot water from deep inside the earth, converts that into steam to drive the generator turbines. And when the steam cools, it condenses into water and is injected into the earth to be used all over again. Most geothermal plants that they're building today are in this category rather than the first one, which is probably the highest number that are currently in existence. Then lastly, we have the binary cycle power plants, and these transfer the heat from geothermal hot water to another liquid, which the heat causes the second liquid to turn into a steam, which is used to drive the generator turbine. Okay, but in all of these cases, you're requiring very high temperatures, somewhere between 300 and 700 degrees Fahrenheit. Okay, and so that's one of the limitations. Okay. So there are 3 types of geothermal power plants. This one is the dry steam. You can see in the picture there on the right. Okay. So again, the production well is bringing it up, and then you've got all that steam that's going to turn the turbine, and then they inject the water back into the ground to be reused. Here's a flash steam point doing the same sort of thing. Okay, but we're going to go ahead and turn the water into steam above ground instead of taking steam from the ground. And then the last one is going to be the binary plant, which is going to have the hot water go ahead and heat a different fluid into a steam, which is then going to turn the turbines. So in all of these examples, you're pulling up this material from the ground, whether it's hot water or steam, which is extracted from the earth there in 1. Then in 2, that steam, whether it was directly pulled or we need to convert the liquid into steam, is going to go ahead and turn the turbine motors in 3. And then once it turns the turbine motors, you're going to have some sort of cooling process, which 4 is then going to go ahead and return that back into the ground through some sort of injection well so that it can be reheated and reused all over again. And this is what those geothermal power plant piping look like. You saw those in the video. Okay. So the video did a good job going over this as well. Geothermal power plants do not burn any fuel. They use the natural heat of the earth to go ahead and heat fluids, typically water, to generate electricity. So their emission levels are incredibly low. They release less than 1% of carbon dioxide emissions of a fossil fuel plant. So much, much cleaner than fossil fuels. They use scrubber systems to clean the air of any hydrogen sulfide or any other potentially dangerous chemicals that could cause things like acid rain. And then emits 97% less acid rain causing sulfur compounds than fossil fuel plants. So what about here in the US? How are we using geothermal? Well, in the US, we are now the world's largest geothermal producer. Current bills are being processed to give research towards geothermal projects about $500 million, pushing large scale production so that we could capitalize on what we're already starting to use. Most of the geothermal reservoirs in the US are located in western states, Alaska and Hawaii in particular. They have very high geothermal. They're on that ring of fire that we were talking about earlier. California generates the most electricity from geothermal right now, however, and they have one site known as the Geysers, which has a dry steam reservoir in Northern California, and it's the largest known dry steam field in the world and has been producing electricity since 1960, although it's been updated since then. Okay. There are 7 states in the US that currently have geothermal power plants, Alaska and Hawaii, along with California. I don't remember the other ones off the top of my head. And in 2008, the US geothermal power plants produced 0.4% of total electricity in the United States. That is on the rise and looks to continue to do so. So here is the continental United States. We already know Alaska and Hawaii have them. You can see the geothermal energy, those bright red spots there. Those are definitely places that could potentially tap into more of this as a resource for energy. Okay, so we've been using geothermal for a long time. It was originally used for bathing in Paleolithic times. The ancient Romans used it as central heating system for bathing and heating homes and floors. In 1892, America's first district heating system was put into place using geothermal. And the first geothermal power plant was actually used in 1904 in Larderello, Italy. In 1926, a deep geothermal well was used to heat greenhouses. In 1960, Pacific Gas and Electric was the first successful geothermal electrical power plant in the US at the Geysers, and this is that power plant right here. Obviously, it's been updated, but this is the Geysers in California. Okay. The first turbine that they actually put in back in 1960 actually lasted 30 years, and so that's pretty good. And so we have another set of turbines now, but this is definitely a potential long-term energy source. So what are the benefits, the effects? Okay. It is very renewable, very sustainable. As long as the planet's alive, we have geothermal energy. It leaves almost no footprint above ground or in terms of its environmental impact. Very, very high efficiency and high net yield. So we're going to see some of these others, like we'll briefly talk about hydrogen at the end of this, not such a good net yield. Okay. Most of the hardware used to extract is going to be underground, so minimum use of surface, so you can actually use the surface potentially for other things. Easy to operate, open up the economy to produce more jobs, new energy sources. Very reliable as it runs 24 hours a day. We don't have the intermittency that we see with, say, solar or wind, for example. Very clean, no air pollution, no greenhouse gases. Can help decrease dependence on foreign oil. We don't have to transport it. It's directly converted on site. New facilities produce electricity for about 4.5 cents per kilowatt hour. So pretty good price. And the price is declining while the fossil fuel price is increasing. The US can produce about 950,000 megawatts of power, even though currently we're only at about 2,800 megawatts of power. So there's a lot of room to grow here. This number is going to constantly increase with new technologies and new research. So there's a lot of growth potential in the market with geothermal. But just like all these other renewable energy sources, for all of the benefits, there are always going to be some disadvantages. The initial startup cost is high. We saw this with hydroelectric, and we're going to see it again here when it comes to geothermal. If you do not have scrubbers installed on the plant, and most of the new plants, they're building with them in it, you can contribute to global warming, even though it's very little, and acid rain, which is actually, not quite to the level of fossil fuels, but it can have an impact. Construction of plants can adversely affect the land stability. There have been instances where the drilling in to extract the heated materials can cause some subsidence or sinking of the land, or can actually cause destabilization, leading to earthquakes, things like this. Sources may hold trace amounts of toxic chemicals, so the fluids that are used, the water, may end up with chemicals and toxins in it just from the process. It's incredibly loud. Okay, it is recognized, like wind power, if you're really close to it, to be pretty noisy, but that can improve potentially over time as well. Probably to me, the biggest downside after the high startup cost is that it really is only efficient in certain geologically active areas. So this is not something that could really just be used anywhere. Okay? Water could contain materials that are corrosive, which shortens the lifespan of the turbines. But as you saw with the geysers, 30 years is pretty good, I think. Um, can't provide for our current energy needs with what we currently have. There would be a lot of ramp up needed. So we would have to expend all that initial capital to go ahead and build the power plants, to ramp up the production to get more energy out of this particular form. And it's not like wind where you can go ahead and have a whole wind farm up in a single year. This is going to take some time, some investment, some process to get to that point. Um, the piping systems can require a fair amount of land. So while the direct portion is not too bad, and it uses water, in many cases, it's going to use a lot of fresh water. And so water becoming more scarce, this always is a potential problem. However, one of the big victories, or one of the leaders that I think we should look at, is Iceland. Iceland plans to run its entire economy on renewable energy, hydropower, geothermal, and wind, and to use these resources to produce hydrogen gas for running its motor vehicles and ships by the year 2050. So they are looking to be completely off of fossil fuels by the year 2050, which is pretty impressive when you stop to think about it. Okay. And it's, before you think, oh, it's some tiny little Iceland island, no big deal. It's pretty good sized. I mean, this is a picture again of Reykjavik, a different one than what you saw before. But this is noted around the world as probably one of the most exemplary green cities. And here is an example of direct use application. These are bathers at Blue Lagoon thermal bath in Reykjavik, Iceland. And you can actually see the power plant behind. So they're using this not only for a day spa, but also for a power plant. Okay, here's another one. This is the Neslaver power plant, which is also in Iceland. And I put that little inset picture there so you can see that not too far from the actual power plant, there's a whole bunch of people swimming in the hot springs again. So overall, geothermal appears to be a very sound solution for our energy needs. It has the ability to expand, has very few environmental impacts, and once it's established, even though it has an high initial cost, it's pretty efficient and pretty cheap, but it's absolutely renewable. Okay. Now, a little, still another fuel source, but not directly related. I want to talk really quickly about fuel, just hydrogen fuel, just so you can see it. Now, hydrogen is a very clean energy source as long as it's not produced using fossil fuels. But while it is a cool energy source and very clean when you burn it, it has a negative net energy yield. So it takes more energy to produce it than you get from it. Okay. So as we use hydrogen as a fuel, we are eliminating most air pollution problems and reduces the threats of global warming. But we have to get it out of something, because typically hydrogen gas is locked in water or in other organic compounds. You don't find a whole lot of free hydrogen. CO2 levels are dependent on the method of hydrogen production. So we could be greatly improving our economy if we're using renewable energy to go ahead and produce the hydrogen fuel, which is what Iceland's looking to do. But if you're using fossil fuels to produce your hydrogen fuel, because it has a net loss of energy, not super efficient. The other issue that we're going to have to deal with is not just the cost of production, but then we have to store the liquid hydrogen somewhere. And again, it has a net negative energy yield. Okay, so definitely there is potential there as a clean fuel source, and it has a lot of power, a lot of bang for the buck, but we have to make it. It's not something that exists in huge quantities freely around us. All right, guys, that's what I've got for you. Stay healthy, stay safe, and I'll talk to you soon. So long.